slightly more complicated one. I just mentioned in the bell work that a lot of times when you have a tangent or a cotangent, things like that, one thing that you can do with them is write them in terms of the sines and the cosines. So the top one, you can do this. So in the bottom one, you can do this. And when you have fractions in a fraction, we would like to probably be able to flip the second one and multiply it out. So what we're going to do here, but that means you need a common denominator. So you need to write this over the cosine, and you need to write this one over the sine. Okay, so what I'm going to do here then is multiply by the cosine of theta over the cosine of theta. Okay, so that in the top one, I'm going to get the cosine of theta times the sine squared. Okay, that's now over the cosine as well. Okay, so that would be that first fraction. And then minus the sine of theta over the cosine of theta. So here's the top of the fraction. Now, it doesn't seem like I'm getting anywhere yet. It's going to be a moment yet before you can see maybe what happens. And then you do the same thing here. Okay, you combine the fractions so that you have one fraction. So here you need a sine and a sine. So on this one, I'm going to get the sine of theta times the cosine squared of theta. Okay, and that's now all over the sine of theta, which was my common denominator. And then here, subtract the cosine of theta over the sine of theta. So I'm at this point now. I'll wait for a second. So this is what I have, and it doesn't look great yet. Okay, I'm not seeing a lot of stuff happening. Usually at this point we'd be able to cancel things already, but this one's more challenging. Is everybody up to that point? Copied? Alright, I'm still going to flip that second one and see what happens. Maybe when I flip things, stuff cancels. And the answer to that's going to be no again. So flipping this one here, the sine should be up like this. And then this part should be in the bottom. So sine theta cosine squared minus cosine. Oh, that doesn't help much, because even these two don't cancel. The sine and the cosine are not canceling. And so then you just have to sort of get lucky to see that you can actually factor some things here, and when you factor stuff, you end up with sort of what you want. Now the only clue that we have here that we might want to factor is because the tangent squared, okay, one way that you can write the tangent squared is sine squared over cosine squared. Okay, and I do have a sine over here, right? I have a sine over here, and I have a cosine over here, so I'm halfway there. As long as I can get a bunch of stuff to cancel and somehow get another sine. Well, you can get another sine. The other sine that I need is going to come from here. I have this sine here and that sine there. So can I factor that? Right, cosine theta sine theta minus 1, right? Yes? The minus 1 comes if I take the sine out of here. Sine divided by sine is 1. You still need that spot. And the same thing happens over here. That's a cosine squared and that's a cosine. So I'm going to be able to take that out. So this is the first fraction. Here's my second fraction. So in the second fraction, when you take out the cosine of theta, what you're left with is, I need to scoot that over a little bit, so I don't have a lot else. So if I take that cosine of theta out, what I'm left with is sine theta cosine theta minus 1. Now let's see, what did I not use yet? So I still need this one up on top, right? So there's the other sine that I need. So I'm almost there, because sine times sine is sine squared. And here I still needed the other cosine. So, well, these big things, yeah, they're going to cancel, because cosine times sine is the same as sine times cosine, right? So here's your cancellation. All this cancels itself out. Leaves you with what? which is, and that's what we wanted. A little more challenging. Okay? Okay. This one I already did. That's basically B from a while back, but you can, on this one, I don't know why I put this one in. So both sides sort of seem the same thing here, right? So there are two ways that you can go here, and I don't want to do the whole thing because we've done this already a little bit. So if I want to work on the left, which is what we usually end up doing, this 1 minus sign is giving me a hint. Try 1 plus the sign and 1 plus the sine of theta. Okay, maybe I will write this whole thing out. So that's 1 minus the sine squared, right? And in the top you get the cosine of theta times 1 plus the sine of theta. Yes? And 1 minus the sine squared is? It's the cosine squared. This one cancels with this one. So what I'm left with is 1 plus the sine of theta divided by a cosine of theta, which is what I had over here. It would work the same way if you'd worked on the left and did 1 minus the sine of theta. Then you get your conjugate pair in the top. You're going to replace it with the cosine, and you get cosine theta 1 minus sine. Okay, so this, yes? Okay. You mean from here to here? Yeah. Isn't 1 minus sine squared equal to the cosine squared? Yeah? Okay. So here, the second way would be to work on the second one. And I guess this one is, I'm not doing the whole way through, sorry. But you end up the same way, except you end up with the one on the left. So if you have a choice, it doesn't really matter. Okay, but you've seen me do that actually already. So move on up. Okay, the cotangent squared here is sort of the easy part. So this one's in here to show you that you don't always work left. Sometimes you work on the right. The cosecant is, I'm going to rewrite the cosecant. The cosecant is 1 over the sine of theta. Alright, and then you see how I ended up with a fraction and a fraction again? Alright, well usually it's just sort of not a rule of thumb, but it generally means that you will want to add these somehow, so I need to multiply by sine over sine here. So I'm going to get 1 minus, and sine theta times itself is sine squared of theta. I get that all over the sine of theta, right? And then I'm dividing that by 1 more sine of theta. So sorry about all the signs, but that's just the way this is. So we're good? And when you divide a fraction by something else, you need to flip the second thing, right? So instead of dividing, I'm going to flip this. So this ends up being 1 over the sine of theta. Keeping in mind that I'm working towards a cotangent squared, so I'm almost there. Sine squared is in the bottom. What can you do in the top? 1 minus sine squared is? Cosine squared. And cosine squared divided by sine squared is? Cotangent squared. And this is what I hinted at in the bell work. Don't leave this step here. Okay, go one more and show me what you got right there. Okay? Alright, you got one left. It looks like a really challenging one, but it's not. Don't get freaked out by exponents initially. I know that's a sine cubed. Not a big deal. What can you do with the cosecant? That's 1 over the sine. Okay. especially if you have a combination of like sines and cosecants or cosines and secants, rewrite the secants and the cosecants as the inverse. Because what happens here? This sine is going to cancel one of those, right? So that ends up being 1 minus the sine squared. And 1 is minus the sine squared is cosine squared. Okay, so that one's actually nice and easy. I just didn't want you to freak out when you saw a cube or a 4 or something like that. So the last slide is just general guidelines, and I've sort of hinted at these. So, you know, start on this more complicated side, rewrite sums or differences of quotients as single quotients. That's the thing when I said you got a fraction and a fraction, make it into one fraction. Writing in terms of sines and cosines often helps. And, you know, obviously you need to keep in mind where you're trying to get at. But the idea, for me, the thing there is that you should work on one side of the equation only. So don't cross multiply. That's a no-no when you do these things. Okay, work on the left side towards the goal, and you can work on the left a little bit and then work on the right and meet in the middle, but don't work on the left, work on the right, and then cross multiply and things like that. So but generally we only need to work on one side. Okay.